I'm Mark Sponsler, and welcome to the StormSurf Video Surf Forecast for the week starting Sunday, October 11th. StormSurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype. Looking at significant wave heights for the North Pacific Ocean, we see almost a gale producing 16 or 17 foot seas off of the Pacific Northwest. But other than that, a pretty calm pattern in control for the moment. The good news is it isn't going to last for very long. As usual, we'll start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they form, help direct their track. We're looking for a trough that is a dip in the jet going to the south, and we don't see it anywhere. But what we do see is the jet in a reasonably good position, running west to east on about the 40 north latitude line, making it up to about 45 north, pushing into the U.S. west coast. Winds up to 160 knots in one pocket over the date line. But in general, the jet pretty cohesive and looking reasonably decent, especially given what's going on meteorologically. And that's good news. Anyway, we'll move out. So we're looking for, again, a trough, a dip in the jet. And as we get into Tuesday, we start to see a trough developing here in the Western Gulf. And what that does, that helps create like an eddy, a counterclockwise flow aloft in the atmosphere and down at the ocean surface. That is the hallmark of low pressure. And if that low pressure is strong enough, it generates winds. If the winds are strong enough, they generate seas. Seas, as they radiate away from the fetch area, if they're high enough, turn into swell. Swell, when it hits your beach, turns into surf. So it's important to have good, strong winds pushing down into the trough to get the circulation going. All right, and we don't really see that as of Tuesday morning, but as we get into Tuesday evening, we have up to 140 knot winds feeding this little micro trough. We also have a ridge, the exact opposite of trough, that is the jet pushing to the north. That helps create high pressure down aloft. When you get a low pressure here and a high pressure here in close proximity together, that forms what's known as a gradient. That is, the isobars tighten between the two pressure systems and generate wind. So there is some potential right here on Tuesday night, but notice that this trough starts getting pinched off really quick as we get into Wednesday, and even more so into the evening. That doesn't open up enough space to allow good circulation to form. So that probably isn't going to do a whole lot other than maybe create some wind swell. You'll get so if you have high pressure here, low pressure here, you'll still get north winds, maybe targeting Hawaii, and that's good for maybe some wind swell. And then we're into Thursday night. That continues, maybe even some weather for the Hawaiian Islands. But then as we get into Saturday, notice the jet building with winds to 190 knots and a new trough looking to start carving out. Again, pretty pinched, but not completely out of the picture. And again, the jet pretty consolidated. Notice this massive ridge here over the U.S. West Coast. That's what's keeping things high and dry. Weather systems follow the jet right up into Alaska, completely bypassing even the Pacific Northwest, even British Columbia. It's up into northern Canada and Alaska. As we get into Sunday, and then where are we? Sunday night, the trough hanging on, but looking a little weaker. But the good news is the jet's still consolidated, still has wind energy, so all hope is not lost. Let's go take a look down at the surface and see the effect of the jet stream on lower level circulation. Here we are, surface level pressure, surface level winds today. Little low pressure, we see it here. What is that? About 1,004 millibars. What we really want to see is something like in the lines of about a 960 millibar low. So this is not even in the ballpark. Tiny area, 30 knot winds. That's it. No swell. Probably not even any wind swell for California to result, but certainly for Oregon and Washington. All right, so we put this into motion. That low moves inland. High pressure sets up off the California coast. You notice 20 knot winds building there. We'll get another little low. Tuesday develops right off of Vancouver Island, quickly moves inland, no hope there. And then we know there's a trough right here as we get into Wednesday. Sure enough, there's high pressure, 1036 millibar high. Let's see if the low develops at all kind of 1,008 millibars. That's not much of a low. Oh, there we go. 35 knot winds, and then quickly fading out. So no hope from that trough, really. But fetch aimed at Hawaii, 20, 25 knot winds. That's good for wind swell as we get into Friday. Then remember, there's a second trough behind that. Sure enough, there we go. Supposedly 40 knot northwest winds falling southeast. And then another low right behind that as we get into Sunday during the day. There's actually a gale, maybe a storm, 50 knot winds. Almost, I see one pixel there, a 55 knot wind. So that would be a storm. Pushing towards the U.S. West Coast. If you believe a model a week out, well, then I've got a bridge to sell you. But the good news is at least there's something on the models. That is good news. Maybe it'll develop, maybe it won't. But we'll say maybe the odds are slightly in our favor. It's better than where we are now, where virtually nothing's going on. All right, let's go take a look at the effect of those winds on the ocean surface. All right, so here we are. Not a whole lot going on. Pretty calm sea state. We know that. We're waiting to see. We're into Tuesday. Then here's the wind swell for Hawaii. What is that? So that's 8, 9, 10, 11 foot seas. Yes, we're really here talking about 11 and 12 foot seas when, our minimum threshold is 30 feet. But okay, wind swell for Hawaii. You can actually see it impacting the Hawaiian Islands on Friday. And then things are supposed to get interesting. Let's see what we get out of the first little system. Okay, 22 foot seas on Saturday morning, building to 26 foot seas. So there could be some little swell both for Hawaii and the U.S. West Coast from that. And then another system right behind. There we go. 33 foot seas. Looking a little better. Not a huge system. And again, a week out. But there is potential. 2 systems on the charts. We'll take anything we can get at this point in time. And then looking at the southern hemisphere, we're back to, Monday night a week ago. A little gale pushed under New Zealand. And we're talking tiny here. 28.7 foot seas right there. Max seas over the whole domain identified down here with the location and the winds in that area, 41.5 knots. All right. And we'll put that into motion. That gale continues to push east, 29 foot seas, 28 foot seas. Tried to redevelop a little bit on Wednesday with 30 foot seas over a tiny area. And then finally got organized on Wednesday night. But the fetch was all aimed southeast, not at us. Maybe some small, really tiny swell for Hawaii and the U.S. West Coast. Hawaii a week out, so that'd be, when did this start? We'll roll this out here. Let's take it the whole way out. We're into Friday night. Another little gale developed, but not much. Probably nothing from any of that. And there we are. Okay, so this whole thing started on, on Monday night. So maybe Tuesday of this week, maybe something for Hawaii, Tuesday, Wednesday, Thursday, and maybe the U.S. West Coast later in the work week. But nothing very interesting and no real size expected. And then we look forward. Here we are today, just doing a quick glance. There is supposed to be this gale that develops, was it Monday night, just in the far southeast Pacific, which sees supposedly building to 41.3 feet on Tuesday morning. Now, the cutoff for Southern California is 117, 118 west, right in there. Most of this energy is aimed almost due east, so very minimal swell probably radiating a week later up into California. So that'd be a week from like Tuesday or Wednesday, something like that. Then after that, we'll just blast through this. We already cheated and look, there's really nothing on the charts. And the South Pacific pretty much goes to sleep at that point in time. Next up, looking for wind swell. So we have a little bit of a fetch here south of or east of Hawaii right there. Not a whole lot. And a little bit off the California coast. Maybe good for bare minimal wind swell. So we get into Monday. Fetch continues off of California, 20, 25 knot winds, and probably next to nothing for Hawaii, but who knows. Low pressure in the Gulf of Alaska. In fact, let's go back. Maybe that'd be good for some wind swell for exposed breaks in Northern California, like north of Point Reyes, something like that. But as we get into Tuesday, Wednesday, high pressure, 1028 millibars takes over. North winds start blowing, even east winds a little bit east of the Hawaiian Islands. But mainly, this looks like a California wind swell producing event centered over Cape Mendocino, almost like a summertime pressure gradient here. High pressure up here, create a heat low inland, creates a gradient and north winds. So wind swell for down into central California Wednesday and Thursday, and maybe even Friday, and then the gradient starts fading, most of its fetch aimed off the coast, and things go pretty quiet as we get into Saturday and Sunday. But the Gulf of Alaska, theoretically, is to wake up, and that is what we really want to see this time of year. Quick look for precipitation potential for California right there. Whatever we were going to get, we've had already. High pressure in control, we saw that already. That's going to make the wind swell. Nary a drop of precip as we get into the, second or third week of October. Typically the first rain in the San Francisco Bay Area. Maybe you get a little bit around the 15th of October, but by Halloween, that's typically where you see your first measurable precip. So far, we're kind of on track. Depends what these systems do. Maybe they'll work their way in, maybe they won't, hard to say, to see whether we stay on track or not. And then a quick look at the snow dashboard for Tahoe. We're looking at squall, no snow forecast. The culprit, freezing, well, no precip for one, and temperatures. You hear where the white is where the freezing level is, so 13,000 feet or higher than 14,000 feet as we get into the 14th and 15th, and still no freezing temperatures down at this line here. That's the peak of squall, that's the bottom of squall. Nothing even close anywhere for the next 10 days. All right, let's take a look long-term. What's going on with the Madden-Julian Oscillation, that periodic weather oscillation that, when in the active phase, helps support storm formation, and, of course, the El Niño Southern Oscillation, which, of course, is in the La Niña phase right now. As usual, we start by looking for signs of the active phase of the MJO, that periodic weather oscillation that moves around the planet. There's an inactive phase and an active phase. Both on opposite sides of the planet. So wherever the active phase is, the inactive phase is on the other side of the planet. When the active phase is over the Pacific, it reduces trades, if not out and out reverses them. It acts like a low pressure system. Takes about 3 to 4 weeks to traverse from the West Pacific to the East Pacific. And when it does, it imparts energy to the jet stream, helps feed the storm track, and also, if it's strong enough, can create westerly wind bursts, which in turn can kick off El Nino, but we don't foresee that happening anytime soon. All right, so first off, we're looking at winds, the arrows. The bigger the arrow, the stronger the winds. Winds out of the east over the East Pacific, that's trades. Same thing over the Central Pacific, and in the Kelvin wave generation area, the far West Pacific, from 135 west to 135 east to 170 west. 5 degrees north and south of the equator. You draw a box in your mind there. When you get the strong active phase over there and trades reverse, you can get a Kelvin wave. And again, that is what can help kick off El Nino. All right, but we're not seeing any signs of that. But it's not the actual winds, it's anomalies. Differences from normal for this time of year. That's what really matters. We see winds out of the east. So trades stronger than normal over the East Pacific, over the Central Pacific, and moderately strong trades, stronger than normal over the Kelvin wave generation area, indicating the inactive phase of the MJO, not the active phase, the inactive phase. Looking at the forecast for the next 7 days, all right, this is the whole planet on one chart. The date line is 180 west. This is winds on the equator. Blues are easterly anomalies, stronger than normal trades. Oranges and yellows and reds, westerly anomalies. All right, and so the Kelvin wave generation area starts here, 135 east, and goes to about 170 west. And the forecast, well, you can see past performance here in early September. I mean, the pattern is easterly anomalies in the Kelvin wave generation area and over the date line for the past month. And if anything, expecting to build and continue for the next week. unchanged, strong easterly anomalies. This is not a sign of the active phase of the MJO, but is in fact a sign at least of the inactive phase of the MJO, or perhaps something stronger. Also notice westerly anomalies balled up in this area, 60 east, 90 east. That's the Indian Ocean, and there's a reason for that. We'll get into that in a little bit. All right, next up, outgoing long wave radiation. That is fancy words for cloud cover. More sunlight that bounces off the ocean surface. That means there's no clouds. That means there's high pressure. But when you see these blues are less sunlight reflectivity. That means the active phase of the MJO. All right, so here's South America. Here's Central America. The equator, EQ, right there. New Guinea, Australia, you get it. Kelvin wave generation area right here. And we have blues, which is the active phase of the MJO. Now, this is exactly the opposite of what all the wind data is saying. You would think that you'd have weaker than normal trades here, or out-and-out westerly anomalies, but no, we have easterly anomalies. We were saying it looks like the inactive phase of the MJO. So something strange is going on here, but we all know what that is. We'll get into that in a second. But anyway, supposedly the active phase of the MJO is occurring now and is supposed to continue 5 days, 10 days, 15 days from now. That per the statistic model. And the dynamic model basically says the same thing, maybe not quite as strong, but looks like the active phase by both of these models is in control. Then where are our westerly anomalies? We want those because that's what imparts energy to the jet stream and feeds the storm track, and we're not seeing it. Let's keep digging. So let's look at phase diagrams, these two phase diagrams. One is the statistic model, one is the dynamic model. What are we looking at? The circle here. Assume you're looking down on the North Pole. And the MJO travels from west to east around the equator, so out here around the edges of the equator, from the Indian Ocean to the maritime continent, over the West Pacific, East Pacific, under the United States, across the Atlantic, over North Africa, and back to the Indian Ocean. You can sort of see that's the forecast, the way the MJO goes. The active phase of the MJO, right here, over the maritime continent, so consistent with the previous two charts. And the further the heavy dot is away from this circle, the stronger it is. So we'll say a weak to modest active MJO, and these are the three different forecast tracks for the model for the active phase, moving into the West Pacific, but for the most part exceedingly weak, other than this one track that says maybe modest. And then the dynamic model saying the active phase of the MJO, yeah, kind of moderate, moving off to the east, taking its time, not even making it to the West Pacific 2 weeks from now. 40-day upper level model. All right, so this shows you areas favorable for precipitation. The greens are favorable for precipitation, and that is basically another sign of the active phase of the MJO. So we have South America here, Central America there, New Guinea there. 0 is the equator right there. Date line runs right around there. Kelvin wave generation area right here. The greens, areas favorable for precipitation. The active phase of the MJO is in play right now. So we've got all the models saying the active phase is in play, but we've got real confirmed data from the TAO buoy array saying winds are pretty strong out of the east, which is not at all what you would expect during the active phase of the MJO. All right, active phase of the MJO traversing its way across the Pacific from, we'll say October, 11th today, through about November 5th. So that's, about 3 weeks? It's about normal. Then after that, the inactive phase of the MJO, and a little bit more coherent, and it making its way over in the West Pacific, let's say Halloween into about Thanksgiving, and then behind that, maybe a weak active phase developing. Let's dig a little more. The CFS model, 30-day CFS model. All right, whole planet on one chart. Date line runs right up the middle here. Kelvin wave generation area starts here, goes to about here. Same deal. You see the blues, those are easterly anomalies. The last active phase of the MJO we saw was in middle of August. Since then, it's that black contour, solid contour. That's the active phase of the MJO. There's a little hint of an inactive phase then nothing. The forecast is here, and we see, well, sort of, there's no coherent, I'll just say it, there's pieces and bits of things, but there's no coherent active phase like there is up here that is moving from west to east. So basically no coherent MJO activity. Blues in the Kelvin wave generation area from there to there, meaning easterly anomalies, maybe weakening a little bit for a moment and then building very strong as we move into November. So if we are in the active phase of the MJO now, and you can actually see, maybe you could guess that it's here doing this thing, and we have easterly anomalies, imagine what's going to happen when we move out of the active phase into the inactive phase in early November. This model says strong easterly anomalies, and I'm sure that is the case. We'll talk more about that in a minute. And then finally, the 3-month CFS model. This is a little different. The forecast goes up here. This is past performance here. We'll overlay the MJO. Here we go. Oops. Oh, wrong one. There we go. We want 850 millibar. All right, so actually we'll turn it off and look for a second. We see blue. Blue, 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 blue. A little bit of yellow right there. So one would guess, maybe an active phase after like somewhere around Thanksgiving, and then maybe a stronger one around Christmas, maybe. Let's overlay the MJO. All right, so here is our active phase of the MJO, about to move into the Kelvin wave generation area in a day or so. Expected to continue. Now this says the whole way through almost to Thanksgiving. Other models thinking otherwise. There is definitely some disparity between the models, but easterly anomalies, even this active phase, weak as it is, barely just gets a little bit of westerly anomalies. And then as we get into the November time frame, stronger inactive phase of the MJO, stronger easterly anomalies, and then the model is again teasing, says, yeah, a very strong active phase of the MJO around Christmas. Well, you know what? This one was previously somewhere in the October-November time frame, and it's down to nothing. So this model is grossly overhyping these systems 3 months out, but pretty good in the short term. All right, let's overlay the low-pass filter, and then we can have a discussion about what's really going on. All right, so dotted contour, high-pressure bias. We've been talking about this. It's been in place. The date line is right there, right? Kelvin wave generation area starting there, 135 east to 170 west. So high pressure in control of the Kelvin wave generation area and the date line, and for that part, the whole Pacific California is at 120 west. So you see, high pressure is completely in control of the Pacific Ocean and looks to be that way at least through January and probably beyond that. That's classic La Nina symptoms. All right, so we have this theoretical active phase of the MJO. It's supposedly in place right now, but all we have is easterly anomalies. What's going on? This is classic La Nina setup. The other thing is the low pressure bias, the solid contour, is over the Indian Ocean, 60 east, 80 east, something like that. So what this means is if there's any low pressure anywhere, it's going to be in the Indian Ocean, and this is the favored location for storm production. Can't wait till next summer. You're going to see it blow up there for sure. And high pressure in control of the Pacific for this winter for all intents and purposes. And even though you get the active phase of the MJO, the La Nina signal trumps it. And basically, even though the active phase wants to produce westerly anomalies, it cannot rise to the occasion. It gets stomped on by La Nina, and you end up with easterly anomalies, which is what we're seeing right now. Now, the flip side is when the inactive phase sets up over the Pacific and you have La Nina here, the two of them are like acting together and they supercharge the easterly anomalies. So when the active phase moves over, it sort of stomps on the easterly anomalies a little bit, but not enough to create real westerly anomalies. But then when the inactive phase and La Nina get in sync, or in phase they call it, then it amplifies the inactive phase and feeds it, and, then you just get a massive upwelling event. Likewise, the reverse is true. When you have the high pressure bias in the Pacific and you get the active phase of the MJO, they feed each other and you get massive westerly anomalies. We've been in that kind of mode for a couple years now, and so it's not surprising that the system has broken down and La Nina is in effect. So now let's go into the El Nino La Nina discussion. First bit of data or symptoms we're looking at is subsurface ocean temperatures. This is down in the ocean, not the surface, below the surface. This is the West Pacific here, East Pacific here. This is data from the TAO buoy array, the series of buoys strung across the equator. These are the anchor lines on the buoys, south of Mexico, south of California, almost south of Hawaii here, out towards the dateline, the whole way across the Pacific. The X's are the sensors on those anchor lines. Data is collected, beamed via satellite to a central processing facility. They use a model to try to integrate or smooth out, find out where like areas of water temperature are, and then you get this profile. This is the reds are warmer than normal temperatures. The greens, yellows, lower than normal temperatures. And so you see the 30 degree isotherm is gone. The 29 degree isotherm in the far West Pacific. The 28 degree isotherm about where it was last week, making it to about the dateline. 24 degree isotherm, pretty much unchanged, 135 west. So what this shows is warm water balled up in the West Pacific and a very, very shallow, weak warm layer at mainly controlling the East Pacific. And anomalies, the difference from normal for this time of year, this even spells out the picture a lot better. Warm temperatures, 1 degree above normal. That's not much. And making it to, what is that? Now we'll say 160, 165 west. So being held at bay. East anomalies, we know east trades, nuking, creating upwelling, -3 degree centigrade. That's like, 5 degrees Fahrenheit roughly. Colder than normal temperatures, filling the whole way from Ecuador, the whole way out to, where's the dateline here? Right there. And even east of the dateline, nary a drop of warm water. And you want warm water in the Pacific on the equator because warmer than normal water creates evaporation. Evaporation creates clouds, feeds energy to the jet stream, and creates storms. And that's what we want. Cold water, or colder than normal water, creates high pressure, a stable atmosphere, and no storms. Here's a higher res model using the same data and basically painting the same picture. Colder than normal water from Ecuador the whole way, almost filling the entire equatorial Pacific. Not good for storm production. Sea height anomaly chart. Same thing as temperatures. What this does is it's a satellite data, strip out the waves, strip out the wind waves, strip out the tide. And is the ocean's surface higher or lower than normal by centimeters? 15 centimeters, 10 centimeters. We're talking like, little things like that much. But what that suggests is if you have negative anomalies like 10, 15 centimeters below normal, it means cold water at depth, cold water contracts, creates that divot. You also have strong east winds pushing this way, pushes the whole ocean into the West Pacific. You notice the positive anomalies here. And so warm water getting pushed over here and cold water filling the void in the East Pacific. That is, Chile's there, Peru's there, there's the Galapagos, Central America, the equator's right there, the dateline's there, New Guinea there. You get the idea. Cold water from, you can see it, California, the whole way down out to the dateline and beyond on the equator, then the whole way down into Chile. Giant, massive triangle of what appears to be colder than normal water. Classic La Nina symptom. And then just a quick look at the upper ocean, 300 meters of the upper ocean temperature profile. And we can go back to December of last year, but this tells the story right here. Cold water in control. Let's see, so this would be Ecuador here. The dateline is right here. This is back in April. This was the beginning of the La Nina pattern. We had this first pulse. Then it almost looked like we got a Kelvin wave in like July, August, but it really wasn't. It was just a break in the trades. They sort of backed off for a little bit, fed by the active phase of the MJO. And then boom, right back at it again. Warm water building in the West Pacific. At some point, there'll become so much warm water here that it'll start sloshing to the east. But my guess is that's going to be at least a year out. Sea surface temperature anomalies. Just looking at the surface now, the pattern unmistakable. These are different from the differences from normal anomalies. Difference from normal for this time of year. The blues colder than normal. Purples much colder than normal. So what do we have? There's Chile. There's Peru. There's Central America. You see, and all that matters, you go, well, there's lots of warm water here off of California. That'll do something. No, for whatever reason it is, it's the water on the equator, zero, right there. There's zero. That's the equator. And that's what makes the difference. And you just see massive, so this is the equivalent of massive easterly trades creating upwelling, no warm water, and that's what sets the tone. Everywhere north and south of where the cold water is, that's where you have high pressure. And it just, well, that says high pressure from Ecuador the whole way, south of California, south of Mexico, the whole way to the dateline and beyond. Not good for rainfall, not good for snowfall, not good for storm production. What this does is it pushes the jet way far to the north. And so the expectation is all the rainfall will probably push, if it follows anything like normal, is the Pacific Northwest. The stronger this La Nina is, the further north the rain line goes. I mean, typically it's in a normal La Nina, it's somewhere in South Oregon, but maybe it'll be even further north than that this year. This is shaping up to be a fairly strong La Nina. Temperature trend for the past 7 days. The blues are trending colder. Very cold there. So cold from south of mainland Mexico the whole way out to almost the dateline. A little bit of warming here along this area. The official El Nino monitoring region starts at 120 west. There's the equator right there, 0. So from here on out to 170 west, 5 degrees north and south of the equator. So a cooling trend in control. And then the overview picture. Plainly obvious, La Nina cooler than normal water, filling the entire area from Chile, Peru, out to the Galapagos, the whole way out. There's the dateline there. So almost all the equatorial Pacific, there's your massive triangle of cool water. It's more limited to the southern hemisphere. But what this does is when the jet comes along, if there's high pressure here and high pressure here, the jet comes off of like Japan, will start heading north and be way farther north than normal. Same thing in the southern hemisphere, way farther south than normal. And that really makes it so wherever you're going to get storms, for the most part, they are in the West Pacific. And then maybe they'll track down into the U.S. West Coast, but mainly from a pretty steep northerly angle. All right, sea surface temperature trend in the Nino 1.2 region. This is the area right up there along Peru, the Galapagos. Temperatures today, minus 1.479 degrees centigrade below normal. You want to see warmer temperatures? We're not seeing it. It's pretty cold. Has been pretty cold since July. Unchanged there. The Nino 3.4 region, the official El Nino monitoring region, on a steady downward trend since July. Today at minus 1.066. Let's keep that in our mind. We'll need that in a little bit. 1 degree below normal. And you go, that's only 1 degree, or, well, was it like 1.8 degrees Fahrenheit? But it's only half a degree is the difference. Half a degree warmer than normal, half a degree colder than normal is the difference between El Nino and La Nina. And we're double than that. So we're clearly in La Nina territory right now. And no sign that it's going to, that giant pool of cold water isn't magically going to disappear in the next month or 2 or 3. It's there for the duration. It is, our suspicion is, already affecting the global weather circulation. And once that boat sort of moves in a La Nina direction, you're not going to turn it around very quickly. So finally, what's the effect of all that cold water on the atmosphere above the ocean? Look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Darwin, far west Pacific. Tahiti, it's still pretty west Pacific, but it's clearly over the Pacific. When you have lower than normal pressure over the Pacific, the index goes negative. When you have higher than normal pressure, i.e. La Nina, then the index goes positive. Today's value, plus 11.99. When you're consistently in like the 12 range, you're in La Nina territory. All right, we're looking down here. It has been positive for the entire month and strongly positive at times. So let's get an average though, a 30-day average. Well, 12.18. We're in that La Nina zone. Okay, but this is more like the active phase, inactive phase index. But even at that, we haven't been below really 9 at all in a month. Okay, the 30-day average today, 8.26, and it has been steadily, well, it was 3.56 a month ago, up to 8.26, steadily rising, approaching the magic 12 number. This is a lagging indicator. I think we're already there. And every bit of other data we're seeing suggests La Nina is here and it isn't going away. 30-day moving SOI average graphed out. You can see it. We're back April 2019. We were kind of in this, here's negative, almost towards negative 12. Sort of in almost an El Nino-ish type thing in 2019. And then October of 2019, actually I would say it was, September 28th of 2019. That was the last good push of the active phase we'd had. And since then, we've been on a steady upward climb. Yeah, there was an active phase, but the trend steadily rising to today's value. It says 11.3. There's a couple of different indexes we're looking at here. They use different methodologies, but give or take 1 or 2 points, you're still rapidly approaching the plus 12 reading, clearly indicative of a trend towards La Nina. And then finally, the official Nino 3.4 sea surface temperature forecast. Fancy words for the El Nino La Nina forecast from the CFS version 2 model. All right, sea surface temperatures. The colder they are, the more La Nina you are today. So we looked and saw actuals as of today, October 11th, which is about somewhere around there at minus 1.06, I think it was, degrees. This model says, yep, that's right. This says, I'm sorry, I lied. Minus 1.5. So this model is overstating it by half a degree. In reality, we're about here. Okay? No big surprise. This model does tend to overhype it. But it suggests we're going down to the end of December. Almost 2.5 degrees. That's incredibly cold. That would be an extremely strong La Nina. Don't think that's going to happen, but we might get down into the 2-degree range, and that's pretty brutal. That's a pretty solid La Nina signature. So it kind of looks like there's no hope for this winter, but we'll talk about that right now. So the immediate good news is the models are showing hope for storms, maybe 2 of them, at least gales in the Gulf of Alaska, producing some surf. Maybe those gales, was it like Friday, Saturday type time frame, Sunday. So surf, if you're in Hawaii, maybe 2 days later, 3 days for the U.S. West Coast. So let's say 10 days from now. All right, that's good news. Wind swell before then. Okay, that's good. But we still have this issue with La Nina, right? And right now we're in actually the good phase. Active phase, the MJO's in control, and we still have easterly anomalies. Like I said before, once the inactive phase syncs up with the high pressure bias, the La Nina signal in the Pacific, you're going to get really strong easterly anomalies. Now, the question is, does that mean there'll be no surf? No, that does not mean that. It just means the odds are not favorable for big, strong storms, okay? So how can you manage your expectations looking forward? Well, assume there's not going to be a lot of storms. When there are storms, they're not as strong as normal, they don't last as normal, they're not as big as normal, and the winds in the storms aren't as strong as normal, so that means the swells they produce will tend to be smaller, tend to not last as long, and tend to be a little bit weaker, lesser period. That doesn't mean there won't be big surf, or big storms, but it means the probability of that is a lot lower than normal. So the strategy for this year, as we've said before, if there are waves, you better go surf, better make the most of it. And the other thing is, there'll tend to be a lot of high pressure, which means a lot of wind, a lot of northwest winds in California, stronger than normal, nuking trades in Hawaii. So not only will there be smaller surf and not as frequent surf, but when it does happen, odds are supportive of windy conditions, not optimal situation. But it's La Nina. You do what you got to do. If you love surfing, you surf. You make the most of it. If you're out doing other sorts of activities, consider this in your equation of whatever you do to manage safety for your sport or whatever activity it is. Snow-wise, same sort of deal. Jet stream's going to be further north. Snow in California, there will be snow. You better go get it when there is. And don't take your best skis early in the season because it'll probably be pretty rocky. Some of these La Nina years, we're lucky to get 35 or 40-inch base on a really bad one, where personally I prefer a 100-inch base. Yeah, that's great. And then everything's pretty well covered. All the really steep stuff is open. The rocky terrain is well buried. 30-inch base, you'll be lucky to get the blues open. So just sort of manage your expectations. The further north you go, the better, the more precipitation there will be, though. Canada, I just looked, is closed to U.S. citizens. Unless you got some dual citizenship or a reason for being there, you're not going to get in. So manage your trips accordingly. That's not to say that there won't be snow and there won't be a lot of precipitation and snow in some locations, but sort of follow the forecasts as we get deeper into the season. Once we get into January, things will be pretty interesting. We'll see how all this plays out. All right, but the good news is, for now, there are some storms on the charts. Maybe we'll get some surf, and that would be good. All right, if you enjoyed the video, give us a thumbs up. We'd appreciate it. If you haven't subscribed, please subscribe. Ring the bell there. You'll get a notification when we post videos. Comments, always welcome. We try to reply, and we get some pretty thoughtful questions on occasion. So that doesn't mean that I know the answers, but I'll try to steer you in the right direction, at least. All right, that's it for this week. We're going to do it again next week. Same time, same channel. Thanks for watching.